The Stephenson 2 cluster is a young massive collection of supergiant stars in the Milky Way galaxy. It was discovered in 1990 as a cluster of red supergiants in a photographic, deep infrared survey by the astronomer Charles Bruce Stephenson, after whom the cluster is named. So far, as many as 26 red supergiants have been confirmed as members of the cluster, far more than any other known cluster both in and out of the Milky Way. This, of course, includes the star of Stephenson 218, which is one of the largest stars currently known. The mass of the open cluster is estimated at 30,000 solar masses, which makes it the second most massive open cluster in the galaxy. Hi everyone, Vega here, and in today's video we are revisiting the largest known star in our universe. So, let's get to it. With a possible radius of 2,150 times that of the Sun, Stephenson 218 has a volume nearly 10 billion times that of the Sun. If it were placed at the centre of the solar system, its photosphere could potentially engulf the orbit of Saturn. Stephenson 218 shows the traits and properties of a highly luminous and extreme red supergiant, with a spectral type of M6, which is unusual for a supergiant star. This places it right at the top corner of the Hertzsprung-Russell diagram, a region characterised for exceptionally large and luminous low-temperature stars. So you might wonder then, where is Stephenson 218? The best way to find it is to identify the summer triangle of the highly luminous stars of Deneb, Vega and Altair. We draw an imaginary line from Deneb through Altair, and this leads us to the relatively dim star of Alpha Scuti that has a magnitude of plus 3.8, so it may be difficult to find. From there we zoom in and find that the Stephenson cluster, which includes Stephenson 218, is to the south of the Alpha Scuti star. Unfortunately, however, it is too faint to see with the naked eye and has a visual magnitude of over 15, which puts it far out of reach of anything but a powerful telescope. We mentioned in the Barnard star video that sometimes, and in particular, cooler stars can actually have volumetric luminosities that far outweigh their visual light component. With a temperature of just 3,200 Kelvin, Stephenson 218 falls into this category, and if we could see it in the infrared, it would no doubt be much brighter than it currently is to the naked eye. Stephenson 218 is slowly drifting towards our solar system, but at a distance of 19,500 light years. Fortunately, it's not arriving here anytime soon. But let's imagine for a minute that it were. What might we see? The largest star in our local neighbourhood is the red supergiant Betelgeuse, proudly shining in the left shoulder of Orion. Its visual magnitude is roughly 0.58, which places it in the top 20 or so brightest stars on a good day. Stephenson 218, however, is a much larger star than even Betelgeuse. We can see in this graphic that Stephenson has a radius that is almost 2.5 times that of Alpha Orionis, and indeed eclipses the former title holder of UY Scuti. For comparison, we also see the orbits of the planets Saturn and Neptune. So what if Stephenson replaced Betelgeuse some 642 light years from Earth? Would we see something different? In this graphic, we see the beautiful Orion constellation make its way westwards as the night grows long. Slowly though, as the Stephenson star replaces Betelgeuse, it now shines at minus 3.28 apparent magnitudes. We must add the caveat, however, that these figures are based on the largest possible version of Stephenson 218. We're not still fully sure whether indeed it is inside the Stephenson 2 cluster, or it is actually a foreground object, which would obviously change things drastically. In our next graphic, we move ever closer to our solar system and reach the distance of 9 light years. For reference, is roughly the distance of the current brightest non-solar star, Sirius. Sirius shines at a bright minus 1.46 apparent magnitude in our skies. And here we see our moon on the left, above a beautiful city somewhere on Earth. And as we know, the moon can be seen on many days in full daylight. Interestingly now, on the right we see the Stephenson star shining with the same intensity as the moon. At an astonishing 9 light years distance, the Stephenson star now becomes a rival for the second brightest object in the sky, the moon, with both objects now shining with an apparent magnitude of minus 12.74. The moon, however, is 384,000 kilometers away, where Stephenson 218 at 9 light years would be 85 trillion kilometers. On this graphic, Stephenson is 222 million times further away than the moon. Absolutely incredible, isn't it? Now, the moon of course is nearly reflecting the sun's light, but you may begin to wonder then, where might the habitable zone of this star begin and end? Where would a habitable planet like Earth be allowed to have liquid water flow on its surface, given of course the correct atmosphere conditions? Here we see the habitable zone of Stephenson 218. The red hypergiant zone stretches an enormous 1,000 astronomical units across, beginning at 650 astronomical units and ending somewhere around 1400. For reference, that figure is as much as 1/40th of a light year. Unfortunately, however, habitable zones for this type of star are in some ways an irrelevance, because they only remain in their current states for a few million years, which in astronomical terms is of course barely a blink of an eye. The chances therefore of any form of life to evolve in that small time frame seems extremely remote. Eventually these stars collapse in under their own weight, having struck iron on the periodic table, and explode in a supernova, and if any life had occurred, it would surely be the end anyway. Despite its huge volume, Stephenson 218 only has an estimated mass of around 16 solar masses. Therefore the likelihood is that perhaps it would leave behind a neutron star, being too light to collapse into a black hole. Its huge volume should not be confused with its internal power source. There are indeed many stars within 1,000 light years of Earth that are more massive than Stephenson 218. We documented the top 20 in a two-part series on massive stars, so don't forget to check that out if you haven't already, and I'll link it in the card above. As Stephenson 218 approaches our Sun, at a point around 815 astronomical units away, or some 122 billion kilometers, or around 20 times further away from us than the dwarf planet Pluto, it would reach the same magnitude, minus 26.74, as our Sun. Seeing an object that is roughly 20 astronomical units across, from a distance of 850 astronomical units, it would have a clear and defined disk. It would be quite literally enormous in the sky. In our final graphic today, we see what the view might be like if such an event happened. Stephenson 218, now just 815 astronomical units away, shines bright and high in the China sky, almost as if it were the Sun itself. We slowly though see the Sun rise to complement, and now the daylight is dazzlingly bright. It's going to be a very hot day in China. Indeed, the planet itself would not remain safe for humans to habit, along with this gigantic hypergiant so close in our local neighbourhood. Our Sun and all its planets would now be in orbit around Stephenson 218, of course. Objects in our galaxy larger than this wonder star are few and far between. Some might suggest that Sagittarius A black hole could be, but that is barely voluminous enough to fill Mercury's orbit. We have to consider that, short of complex nebulae, Stephenson 218 could well be the largest self-contained structure in our entire galaxy. Its awesome power would light up our skies like the moon from as far away as 9 light years. At 815 astronomical units, 815 times further away from the Sun than ourselves, it would become its rival. Let's hope though that it never comes too close to our safe little corner, because one day it might just go boom in the night, and it would end life on our planet forever. Thanks for watching, and consider subscribing if you haven't already. Thanks for those of you that are regular viewers and subscribers. If you want to support the channel further, you could consider buying me a coffee, and I'll link this in the description. If you have any other videos or subjects that you'd like to see brought to life, don't forget to let me know in the comments below. It could just be your idea next week that shows up. Take good care of yourselves and look after your family and friends well. I'll see you on the next one.